Good afternoon, everyone. So, The Art of Smart Channel is the title, and I, Naoki Watanabe, will be the presenter. So, in this session, I would like to introduce the service called Smart Channel and some unique things that we do in this service. This is Smart Channel UI. So this is at the top of Talk tab in Line App. And this is the small banner area that is Smart Channel. I would like to ask you a question. So Talk tab in this area, have you seen anything that is shown on displayed on this banner? Please raise your hand. Thank you very much. Most of you have seen it, I think. So what is displayed here as a content is personalized for every one of you. So what is displayed here would be different for each of you. And the contents that are displayed are various ones: stamp, weather, horoscope, manga, news. And what is shown here is just one example. There are many other types of contents, and contents type is increasing all the time. So it's not just in Japan, but in Taiwan and Thailand as well, we are distributing the contents. And it's not that the same contents are distributed in other countries. The contents are decided by the country to meet the needs of the users in each country. This is the concept of Smart Channel. In Line, other than chat app, there are many other services. Smart Channel gains information from various services in Line so that the appropriate contents for each user would be shown at the appropriate timing in real time. That is the concept. And the contents, it's not that it can be any contents, but these are contents from services that the user has used in the past. And until now, in Line, we have created recommendation personalizing for each service. But to gather information from across different services to show contents real time is the first time we do this. And I will talk about how we realize this later on. It's not just displaying contents, but we are also particular about the user experience. This is my own experience with Line Manga. When there was a new book published for manga called Kingdom, I had purchased the book before in Line Manga, so that's why this was shown for me. And on this banner, if you tap on it, you can purchase the new book right there and then. So with just a few clicks on the day of the release, you can purchase the new book. So this was a great experience for me. And there are the notifications from the app or from the official account, but you may miss them. And sometimes I see comments on social media and realize it was released. So it was a great convenience for me to know from the banner contents. And so this new manga book publishment notification is a well-received contents, one of the example of good contents. So this service really values the convenience for the users. There are 3 stats shown here to show the size of this. 500 million, this is number of impressions per day. So many contents are shown every day. And globally, we deliver personalized contents to more than 100 million users every day. And the traffic per second is 250,000 requests per second. This is quite sensational, but it's not that this traffic is for every day. This is at the peak traffic of the New Year's Day. So you can see this is a service with such a great size. Now I would like to talk about how we built this large system. And this is the overall flow. In Smart Channel, there are 5 components which are working in an integrated manner. So from all services, services, there's the importer to gather contents from different services, and this is asynchronous. CRS engine would receive requests from LINE app, and in real time, it would select the personalized contents and return them. And in LINE app, the content display and clicked receive event is the event would be received by event tracker, and the log is would be converted to a format that can be used in machine learning by joiner. And lastly, learning worker would do the learning, and learning worker would give the results of the learning for the next release. Next, CRS is Smart Channel Course System, and it stands for Contents Recommender Service. And from CRS engine, it would go in a circle, it would go to learning worker, and then the learning is done. So through this cycle, the system is getting smarter and smarter. From here, I would like to talk about how the contents are personalized. For personalization, there are two layers. The first layer is where for each service, the recommend contents is generated. This service, many of them are already generating recommend. Therefore, we are reusing this feature. So with different logics, we may set the conditions to generate the contents. For example, weather, today's weather or tomorrow's weather, or manga. When there's a new series of manga purchased in the past is published, then there might be a notification or recommend similar to manga to what was purchased in the past. And so recommended contents would be gathered from different services. And we select only one content from contents of different genres for overall optimization. That's the second layer. And I will talk more in detail about the first layer first. So importer, this part would be integrated with different services. And each service has two features, mapping provider and data provider. So from mapping provider, for which users, what contents are displayed, that mapping is stored in HDFS in a file format. And then once the mapping file is stored from the service, the importer API would send notification. Importer, with this notification received, it would receive the mapping file from the HDFS and do the processing. With just mapping, it's just displaying news A or news B. That's all that is known. Therefore, in order to know what title and image is held by the content, the data provider is inquired for master data. Mapping and master data are combined as a set and stored in Redis cluster.
And why do we split mapping providers and data provider? There are two reasons. First, mapping is created based on the previous day's log and therefore needs to create once a day. But the master data is changing always. For instance, the weather may change according to the time, or the articles of the news may be updated. Therefore, the information needs to be fresh. So master data is refreshed anytime. And therefore, these two processes are better or convenient from a precision point of view if they are split into two. The other reason is simple. Mapping provider is made by the machine learning engineers, and the data provider, on the other hand, are made by the server-side engineers of different services. And the people who implement are different, so it is easier to work if they are split into two because of the efficiency. Now, going back to the previous chart, look at the green, the second layer above, and the first layer is individual services, and they are processing the personalization from batch point of view, but this is the overall optimization. Therefore, it is processed real time. And this is architecture. The CRS engine is in charge. This part, this is quite hard, and we worried about this. The first layer from different services, the contents are gathered, that's okay. But from here, this moment, what with the best contents, we must choose one single content. One single content best for that person. That is a key. And the content changes always. And before expressing the content, we need to predict whether the contents matches the users. However, the information that we know in advance is quite few. The static information such as the content categories and the gender and the ages of the users guessed from the line behavior log. And this is such a challenging problem. In order to solve this problem, we use Bandit algorithm. Bandit algorithm, like the picture shows, is to optimize the profit of slot machine. And the slot machine, next to slot machines is a lever, and this is the switch to start slot. And this lever is called arm, and this arm, there are a lot of arms to slot machine. That's why it's called multi-arm bandit problems. And this arm, I am going to use the word arm, so please remember the word arm. There are two key points. We split the flow of the time to multiple rounds. And with one round, there's only one single arm that can be delivered at the same time. And which slot machine has the higher probability of winning is not known in advance. And this is very similar to the problem that we'd like to solve. And from this condition, the reward, in order to optimize the profit, we try to maximize the reward. And the smart channel, the reward is not the profits, but the users satisfied. And Bandit algorithm combines exploration and the exploitation in order to solve these problems. This chart is a concept of exploration and exploitation and how it behaves. To begin with, the information is limited, and therefore, in order to get the data, we need to gather different contents to explore. As the information is stored using the contents of that is learned, try to find the content with high effectiveness. That is an exploitation, but it doesn't switch immediately or clearly like this. As the learning is accumulated, need to do the exploration and also need to increase the ratio of the exploitation to ensure the reward. And blue content A has higher rewards, so it matches the users. And as time goes by, it learns and the probability is converged. And how and what sort of rules do we apply to exploration and exploitation depends on Bandit algorithm implementation. With Smart Channel, we are supporting for algorithm. The Lean UCB algorithm implemented first, and then after that, in order to improve the performance, linear regression and factorization machines additionally implemented. At this moment, we are doing the testing, A/B testing for the performance comparison, and we are using factorization machines overall. And the last neural factorization development is complete recently, so we will do the A/B testing, and if the performance is good, we are going to deploy it overall. And in order to learn it, the Bandit reward must satisfy the user. Then systematically, we need to detect whether the user is satisfied. This is also very difficult. Now I'd like to talk about the variation of the contents. When the Smart Channel banners are shown, the users are likely to behave three different ways. First, to click banners to the contents. This is a positive reaction. Secondly, if the user does nothing, basically a little negative reaction. However, like whether there are some contents, just to look at it will make the user satisfied. Therefore, this is a flat reaction. Lastly, X button. If one clicks this X button, then the banner goes off tentatively, and this is called mute. It's a very strong negative reaction, as we learned. These events are received by event tracker and processed with joiner, and the learning worker will receive it. But there is something that we created. And the user react to the contents, and we have timeline. And on the timeline to the express contents, whether the user clicked or mute, we are going to judge. And so far, so good. But the problem is, if user does nothing, user doesn't do anything, and there's no event if the user doesn't do anything, how systematically do we detect that? That is a problem. The answer is very simple. For a certain time, the system waits for 10 minutes and judges when the 10 minutes elapses, and if there is no click, no mute, we can judge the user didn't do anything. But before then, if the click or mute happens, we adopt it as is. This process, how this process is implemented by system. This is implemented by joiner, and I'd like to explain by steps. If the contents are shown, the impression event, which is the event tracker, the imp event is produced by Kafka and is processed by consumers. In addition to ordinary imp processes, we set 10 minutes timer and put it in other Kafka for task handling. On the other hand, the delay click and mute will simply go through Kafka and is processed and is stored in Redis as is. And the timer goes off, and 10 minutes later, it is processed by joiner, and the Redis is referred, and if there is any click or mute, it is joined and put into Kafka. If nothing happens, that means there was no reaction, so it stays in Kafka. That becomes machine learning inputs. Then the log goes to the learning workers, and the system learns. And how does it learn? For the overall optimization, we split the levels of learning with two axes. One is the user side, the other is content side. The user side, the machine learning infers the age and gender with machine learning. With the content side, the time that the user is looking at, or the contents ID, or the types of contents used. And if you just listen to it, looks at it, you may not be able to understand. So look at the specific examples.
So this is how we would divide the news into arms. So this is the user feature, 20 to 24. There are numbers like this. This is the age. And this is just inferred. So it is a range of 5 years. And below that, there is also gender. On the other hand, this is the contents feature, and next to news icon, there is number and alphabets. These are the article ID. And for each article, age group and gender, the results of users' reaction is shown from 0 to 1. And where it is in green, this means that the score is high and the contents can be recommended to this user. On the other hand, this is another example of weather being split into arms. So the feature is the same as news, but the content feature is different. In weather, the weather type, sunny, cloudy, rain, snow, depending on the weather, the learning is divided. Generally speaking, when the weather is bad, the score goes up. So around here, the score goes up. When the weather is bad, do you have to bring your umbrella, or is there going to be impact on transportation? There is impact on your life, therefore interest will be high for the users. And the score is highest when this is the case. Sunny and later snow when the weather changes during the day. It's true for myself as well. You want to know when the weather turns bad. That's why you have high tendency to click, and that's why score becomes high. It's not shown on this table, but the time of the day from 0 to 23 is also integrated here. And the numbers here are just images. So in in actuality, there is no such extreme differences. So there is only the difference of 0.1 or so. But it is true that the reaction changes depending on the weather. So as we have seen, there are tables with contents, and we have many of these tables. And in this table, it is one row, one line for each content. But for news and weather, there are more detailed learned information. And using these calculated parameters, we would do the ranking real time and decide what contents to display. And there are three things we do for learning implementation. One is that there is huge traffic from lineup. So this is the way to do stable processing for such traffic. Secondly, to handle the large traffic, we also do distribution of processing as much as possible. Thirdly, this is contradicting the second point, but for some processing, if we distribute it, the learning is not efficient. That's why we have some creativity in how we do the distribution. So when we look at the flow to explain, so in lineup, there is a CRS engine which would receive the requests in high volume, and this is 250,000 RPS. CRS engine would do the scoring using ranker online, and then learning process, as shown in learning process, the model parameter is stored in Redis cluster. The banner, after it is displayed, the imp and click events are aggregated, and as I explained, imp is huge in traffic, and then there are multiple nodes for learning, and we do the load balancing. However, if we flow this traffic all at once, then it would be difficult for the learning process. Therefore, we do throttling. So that was the learning dispatcher to do that for load branching. In Bandit learning, there is log data, and for each arm, it is accumulated. So for multiple arms, data would be accumulated. And for example, in this arm, there is a lot of data. Therefore, we do load balancing to use multiple nodes for learning. On the other hand, in this arm, because of less exposure, there is less data being accumulated. So if we distribute the load, the learning would not progress. Therefore, we want to do the learning on the same node. So in order to meet such paradoxical demand, we have split the data into a set K like this. So the split box is called partition. ARM ID and partition ID in the same pair would always be processed in the same node. For example, here, ARM is 3 and partition is 3. On the other hand, for this, ARM is 2 and partition is 1 for this pair. This ARM and partition ID pair is used, and using consistent hash, we fix the node. Consistent hash, we use INX. And this is NGX. And then it goes to learning worker after consistent hashing. And this is the trainer, and Bandit learning occurs here. However, what is learned by worker is not used as is. There is another step of processing. And NGX, through NGX, it goes to the parameter server for processing, and then it is written to model parameter Redis. This is complex, so I will simplify it. So in the first half, this is real-time processing. On the other hand, this learning processing for efficiency, it is asynchronous in a batch. And So there's real-time processing CRS engine, and the processing as a ranker has to be light as much as possible. That is why the complex and heavy computation is done asynchronously on the learning worker side. So this learning processing has real-time processing and asynchronous processing, and parameter server does the synchronization between the two. And the processing of parameter server is explained in a different session in detail. I will explain about that session at the end of this presentation. And the language that is implemented is different. For real-time processing, Java is used because it is used in server-side implementation. And for machine learning, we use Python, which has advantage in computational processing. We had the idea to use Java for all. However, for matrix operation library, C and C++ are also implemented. And then to have a stable service level, we were not confident to just use Java. That is why we have different languages which are linked through API. We call this hetero-architecture. Hetero means heterogeneous. So it means different languages implemented and also implementation of real-time and asynchronous at the same time. So I talked about smart channel, different components, and I think you have now the idea of the flow of optimization. Let me go a little further. So in operation and improvement of this system, we had some struggles, and there are some creative points that we did. Let me start with the test problem. Recommendation test had to be done. However, in the beta environment for test, there wasn't log. Therefore, recommend test cannot be done in the test environment. Of course, we cannot do release without any test. Therefore, we had no choice but to do the test in the production environment. And also, recommend doesn't have the correct answer. So how can we judge that the test is passed? Therefore, we have to expose it to the user to do the evaluation of the performance. That's the only way of doing test. In order to solve this issue, we provide the feature called gradual rollout. So instead of releasing to all users in production environment, we release only to N%, for example, 1 or 5% of users to do the evaluation of the performance, or we indicate the ID so that it is shown only to specific users. This is done for QA. Internally, we have a tool called Libra for supporting this, and this is the image of Libra. So at the bottom, rollout, you can set the exposure percentage, and the change can be done with no deploy, so it is very convenient. Next is recommend performance. Our objective is to make users happy. Therefore, as an indicator, we need to see and monitor whether the users are satisfied. What should we monitor? We decided that we would increase the click, which is positive reaction, and we should reduce mute, which is negative reaction. So we look at the numbers of clicks and mutes as a score, and we monitor it as a KPI, and our target is to increase the score.
Therefore, in order to improve scores, we do A/B testing routinely. I talked about gradual rollout, and the Libra for A/B testing tool is very useful. And the contents of improvement is the improvement of UI, the recommend logic, and also how to change the slicing of bandit arms. And A/B testing configuration is very easy, and this configures A/B testing. This can also be changed anytime online. This is very convenient. With Smart Channel, A/B testing is done every week. So some sort of testing is done every week. And the result of A/B test is put into the data scientist analytics report. This is such a simple example, but actually the number changed in terms of percentages and also judges whether there is any significant differences. We may not have a clear-cut answer of whether A or B, but we may do the additional A/B testing or may analyze with assumptions and analyze the data. So it is very encouraging. And lastly, I'd like to introduce our improvement of Bandit that I was talking about. In fact, there are some disadvantages to the logic that I described earlier. Before the learning starts, it takes 10 minutes. And after the first learnings, the optimization is not working, and therefore we must export. According to this drawing, A, B, and C may be the same percentages, and this is what I mean. Second, is even more important, the user features of Bandit is sliced by age multiplied by gender. And if we separate arms to each individual, the learnings is not converged. But in the real term, can it be personalization? That is a question, and hope that we can optimize personally by user. And therefore, other than the Bandit arm against each content, what sort of reaction did user show? In the past, we have click CTR and X CTR. This is a mute CTR, and this can be considered as additional parameter for optimization. This is a concept image, and by user, by content, it aggregates the past reactions, and the information that is not used is not shown. Therefore, there are some contents without any parameters. And by using these parameters additionally from early stage, we can narrow down the probability. Image-wise, this is what I mean. The users will be able to have the higher probability of the best contents for each user. And we have different approaches, so we still have room for improvements. Lastly, I'd like to introduce some of the future plans. First, life information support. What sort of information is it? The most important information related to your daily life, such as earthquake or the safety information in the region or the disaster information and traffic information, and also hay fever, air conditions, and guerrilla heavy rain is coming soon. What sort of information is convenient for people like you? And smart channel developers are always thinking about it. So if you have any good idea or if you have any request, let us know. Next is Bandit API. I introduced Bandit system, and it's quite challenging to build Bandit system. The smart channel Bandit feature can probably be provided with API. That was a very aspirational project. How do we connect the services? From the connected services, the user IDs and candidate contents IDs are given as sequences, and with Bandit API, we rank and return it. From services, we receive feedback such as in and click information, and the system learns. The Bandit is optimized not necessarily by knowing what the data is in reality, but it learns only the reaction to IDs. It's working as a meta optimizer, that's why it becomes possible. And also, there is a plan to provide recommendations to things other than smart channel. Now we are only providing the talk tab about smart channel, but the core system CRS does not limit the location. So in the line wallet tab and home tab, which is different contents from smart channels, such as the coupons, limited contents in case of wallet is possible. And also the different services, whether the contents are offered, the learned and optimized contents can be returned to services, or the Bandit API, which was learned, can be offered, and also the learned parameters can be provided. We have a plan to give the feedbacks as such. Lastly, I'd like to introduce locations and beacon feature enhancements. This is still in plan, so there's not much specifics yet. But the examples such as the current weather forecast is the likely or estimated residential areas and line use have the weather forecast and cities. But if you travel, you want to know the weather where you're traveling. So we would like to include the improvement of the weather where you are at this moment. And also, this is an event-like thing, but the contents that you can look at the certain locations. And Line has beacon platforms, and the convenient information with beacons or the contents that you have to be there in order to see the contents. So we'd like to have some fun contents, and also we'd like to increase the number of content that the user will feel convenient. Please look forward to it.
はい、私の発表は以上なんですが、
And this concludes my presentation, but I have
スマ
some
ートチャンネルに関するプレゼンテーション
information.
が私が
And the
発表
smart
以外にも3つあり
channel
ます。
presentations
一つ目
are
は
not
今
just
日の
mine,
夕
but
方
there
の
are
セッショ
other
ン
two
スマー
other
トチャンネルのマシ
presentations.
ンラー
In
ニング
this
の部分をより詳し
evening,
く
we
マ
have
シンラーニングのエンジ
the
ニアが
smart
解説
channel
します。
machine learning
このセッショ
session
ンで
for
マ
machine
シンラー
learning
ニングの部分を
engineers.
もっと聞きたかっ
And
た
if
という
you
方は
wish you
ぜ
wanted
ひ
to
聞いて
hear
みて
more
くださ
about
い。
machine learning, please
二
attend
つ
the
目は
session. The
明日の
second
セッション
is
になるんで
tomorrow's
すが、
session,
スマートチャンネルの
the
プロダ
smart
クト
channel
マネジメ
product
ントの話で
management.
す。非常に LINE らしい
Session
やり方で
and
開発
it
さ
is
れている
developed
スマート
with
チャンネルを例
very
に
unique
LINE での
line
ものづくり
method
が
with
どうや
the
って行
smart
われている
channel,
かを
and
話
you
してい
will
ま
be
す。
able to understand how line
三
makes
つ目は
things.
ポスターセ
Third
ッションなんで
is the
2
poster
日間あるんです
session.
が、
So the
スマー
two
トチャンネルではどんな
poster
AB テストが
sessions
ど
for
のよう
2
に行われ
days,
て、
and
実際
smart
どんな
channel
成果があった
shows
のかを解説
how
しています。
A/B testing is done
これら
and
すべ
what
ての
sort
セ
of
ッション、
result it
内容ができ
accomplished.
るだけ
For
重複
all
しな
the
いように
sessions,
工
we
夫
are
していますの
trying
で、
not to
スマートチャ
overlap
ンネ
the
ルに興味
contents.
を持ってい
And
ただけ
if
た
you're
方は、
interested in
全部見
smart
ていただ
channel,
けるとシステ
I
ムの理
hope
解だ
that
けで
you
は
will
なく、
attend the whole
LINE で
session
の
so
開
that
発
you'll
の
be
仕
able to
方っていうの
understand
が
not
見え
just
て
the
くると
system,
思いま
but
す。
be able to
もちろん
understand how
他
the
にも
line is
たくさん楽
developing.
しいセッション
And
あ
there
る
are
の
a
で、
lot of fun
楽しん
sessions
でみてく
as
ださい。
well, so please look forward to it.
はい、この後、アスクザスピーカーとして会
And
場出た
as
ところ
as
に
the
私おりま
speaker,
すので、
I
質
will
問
be
とか
there
感想とか、こう
if
い
you
う
go
コンテ
out
ン
of
ツ欲し
this
いよ
room
みた
and
いな
if you
方
have
は、
any
ぜひお気
questions
軽に
or
声をかけてください。
the feedbacks or
また、
contents
ブ
that
ー
you
スペー
would
ジの
like
方
to
で、
request,
ワーカー
please
ズライナーと
talk to
いう、
me. And
LINE
at
の
the
エン
booth
ジニア
there
の
is a
働き方を紹介
line
するブースがあるんです
engineer
が、今日の17時
work
50分から
style
19時まで
and
私いる予定です
I
の
will
で、
be there
LINE の
until
エンジ
7
ニアに興
o'clock.
味があ
So
るとか、
if you're
LINE で
interested
働い
in
てみたい
becoming
みたいな
line
方は、もし
engineer or
お
if
られ
you
た
want
ら、
to work
ぜ
at
ひ遊
the
びに来てく
line,
ださい。
please come and
以上
see
で
me.
す。長い時間ありがとう
Than
ござい
you
まし
very
た。
much for your attention.